Hello everyone, good evening. In this session, I am going to explain about evapotranspiration. Transpiration is the process by which the moisture absorbed by the roots of the plants and circulated through the plant body returns back to the atmosphere as water vapor breathed out by the stomata of the leaves of the plants. Since transpiration is essentially the evaporation of water from leaf cells, the rate of transpiration is also influenced by all the factors which affect the evaporation. Thus, high temperature, low humidity, and strong wind all tend to increase transpiration. However, in addition to these factors, transpiration is also affected by a few other factors such as the available sunshine, available soil moisture, type and extent of plant growth, etc. The land surfaces which are partially covered with vegetation lose moisture simultaneously through evaporation from the land surface and through transpiration from vegetation. As such, the common practice is to estimate the combined loss of moisture from the land surface through evaporation as well as through transpiration. This combined loss of moisture from the land surface is known as evapotranspiration or consumptive use of water. The term evapotranspiration is defined as the total volume of water per unit area used by the vegetal growth of a given area in transpiration and building of plant tissue and that evaporated from adjacent soil or intercepted precipitation on the area in a specified time. On the screen you can see the factors affecting consumption use of water. The first one is evaporation from the soil. Some percentage of water evaporates. Escape from the soil is evaporation. Second is temperature. Third one is wind velocity. Fourth is relative humidity of air. Fifth is precipitation. Sixth is daytime hours. Seventh is intensity of sunlight. Eighth is soil type and topography. Ninth is type of crop. 10th is cropping pattern. 11th is length of growing season. 12th stage of the growth of the plant. Next is amount of foliage of plants. 14th nature of leaves of plants. 15th method of irrigation. Next is quantity of irrigation water applied, and the last is quantity of readily available soil moisture, etc. These are the some factors affecting consumptive use of water or factors affecting evapotranspiration. Then how to measure this evapotranspiration? So measurement of evapotranspiration. The various methods adopted for determining the consumptive use of water may be broadly classified in two categories. One is direct measurement, second is empirical formula. Direct measurement of consumptive use of water. In this, Soil moisture studies on plots. Tank or lysimeter method, field experimental plots, integration method, inflow and outflow studies for large areas. The first is soil moisture studies on plots. This method is usually employed to determine the consumptive use of water in irrigated field plots in which the soil is fairly uniform and the depth of groundwater is such that it does not affect the soil moisture fluctuations within the root zone. Soil samples are taken before and after irrigation with some samples between irrigations. Usually, a large number of soil samples must be taken at different depths in the roots zone. The moisture content of the soil samples is determined by standard laboratory methods and it is expressed as a percentage of the own dry weight of the soil. From the moisture percentage thus obtained, the quantity of water in hectare meters per hectare removed from the soil evaporation and transpiration is determined by using the formula capital D is equal to small p capital S and small d divided by 100, where P is equal to moisture percentage by weight, S is equal to the apparent specific gravity of the soil, D depth of soil in meter, D depth of water in meter removed from the soil. The total quantity of water removed from the soil during each period is computed, which gives the value of the evapotranspiration for that period, from which evapotranspiration for a 30 days period is determined. The second one is tank or lysimeter method. Tanks are watertight cylindrical containers which are open at one end and are set into the ground with their rim approximately flush with the surface. The tanks are 1 to 3 meter in dia and 2 to 3 meter deep. Usually larger tanks are preferred because they permit more nearly natural root development for the plants grown in the tanks. The consumptive use of water is determined by measuring the quantity of water required to be supplied to maintain satisfactory growth of the plants within the tank. Lysimeters. Lysimeters are similar to tanks with the difference that they have pervious bottoms. In the case of lysimeter, also the plants are grown in the same manner as in the case of tanks. But owing to their pervious bottom, a part of the water applied is allowed to drain through it, and the same is collected in a pan kept below it. The consumptive use of water in this case is therefore given by the difference between the water applied and that draining through the previous bottom and collected in the pan. The advantage in the case of lysimeter is that gravity flow is permitted and hence conditions more close to the natural ones are developed. Third one is field experimental plots. This method is more dependable than the tank and lysimeter method. In this method, Irrigation water is applied to the selected field experimental plots in such a way that there is neither runoff nor deep percolation. Yield obtained from different fields are plotted against the total water used and as basis for arriving at the consumptive use. Those yields are selected which appear to be most profitable. It is seen from observations that for every type of crop, the yield increases rapidly with an increase of water used to a certain point, and then increase with further increase in water. At the break in the curve, the amount of water used is considered as the consumptive use. Fourth one, integration method. In this method, the consumptive use of water is determined by the summation of the products of the first one, consumptive use of water for each crop type times its area, plus consumptive use of water for natural vegetation times its area, plus evaporation from water surface times water surface area, plus evaporation from bare land times its area. For successful application of this method, it is necessary to know the consumptive use of water and the areas of various classes of agriculture crops and natural vegetation, as well as the rate of evaporation from the water surface and bare land and their areas. Thus, in this method, the annual consumption use of water for the entire area is found in hectare meters. Fifth one is inflow and outflow studies for large areas. In this method, the consumptive use of water is determined by measuring the inflow to and the outflow from a selected areas. Thus, if letter U is the consumptive use of water for a certain area, then its value is U is equal to I plus P plus GS minus GE and minus O. Where I is equal to total inflow into the area during a 12 months year. P, yearly precipitation of the area. GS, groundwater storage. GS is groundwater storage of the area at the beginning of the year. GE, groundwater storage of the area at the end. GE means at the end. End. Groundwater storage of the area at the end of the year. O is yearly outflow. O is outflow. Yearly outflow from the area. All these volumes are measured in hectares meters. Further, in this method also annual consumptive use of water for large areas or valleys is on. So this is about the measurement of evapotranspiration methods. Thank you.